Good day, dear learners. Welcome to another episode of Learn Math with Doc Kilma. Are you ready, class, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, class, let's begin. The topic I will be discussing for today's lesson is all about addition or subtraction of linear inequalities. What is the difference between linear equation and linear inequalities? In linear equation, class, we are to determine the exact root of the linear equation, wherein we have the equal sign. While for linear inequalities, we are to determine the solution sets of the linear inequality, wherein we simply have the symbols less than, greater than, less than or equal, or greater than or equal. A solution of an inequality is any value of the variable that makes the inequality true. All of the solutions of an inequality are called the solution set. Example: S is greater than or equal to 5. The solution set of S are 5, 6, 7, 8, 9, 10 up to positive infinity. These sets of numbers are numbers that are greater than or equal to 5. You can graph the solution set on a number line. The symbols less than and greater than indicate an open circle, while the symbols less than or equal and greater than or equal indicate a closed circle. Consider a warm-up drills. Letter A. Compare the given pair of numbers by equal sign, less than, or greater than. Number 1. 8 blank 8. This is simply equal sign. So 8 is equal to 8. Number 2. Negative 3 blank negative 5. Take note, negative 3 is greater than negative 5. Number 3. Negative 9 blank negative 4. Take note, negative 9 is less than negative 4. Number 4. K minus 4 equals 8. In this particular equation, we can simply apply addition property of equality, wherein we can add 4 to both sides of the equation. So we have K minus 4 equals 8. K is just equal to 8 plus 4, or simply K is equal to 12. Number 5. 9 plus P equals negative 7. In this given simple linear equation, we can simply apply subtraction property of equality. We can subtract 9 to both sides of the equation. 9 plus P equals negative 7, where P is equal to negative 7 minus 9. Simplifying further, we have P is equal to negative 16. Take note, when you add or subtract the same number on both sides of an inequality, the resulting statement will still be true. Consider illustrative example. Consider negative 5 is greater than negative 8. Adding 1 to both sides of the inequality, we have negative 5 plus 1 and negative 8 plus 1. Negative 5 plus 1 is negative 4. Negative 8 plus 1 is negative 7. As you can see, negative 4 is still greater than negative 7. Consider again negative 5 is greater than negative 8. If we're going to subtract 1 to both sides of the inequality, we have negative 5 minus 1, negative 8 minus 1. Negative 5 minus 1 is simply negative 6. Negative 8 minus 1 is simply negative 9. As you can see, negative 6 is still greater than negative 9. You can find solution sets of inequalities the same way you find solutions of equations, by isolating the variable. You can also apply the properties of inequality: addition property of inequality, subtraction property of inequality, multiplication property of inequality, and division property of inequality. Consider illustrative example number 1. Solve and graph the following simple linear inequalities. Number 1. N plus 2 is less than 4. In this particular inequality, we can simply apply subtraction property of inequality. Subtract 2 to both sides of the inequality. So we have n plus 2 minus 2 is less than 4 minus 2. From here, we can just cancel 2 and negative 2 since they are additive inverse. So we can cancel 2 and negative 2. So from here, we have n is less than 2. Let's graph. We consider the value of n, which is less than 2 in the inequality. So we have a number line here from negative infinity up to positive infinity. Take note, we're going to draw an open circle to 2. So we have the open circle to 2, and we're going to draw a line segment to the left of 2, since n is less than 2. Hence, the solution set of n are 1, 0, negative 1, negative 2, negative 3, negative 4, up to negative infinity. Consider illustrative example number 2. Solve and graph the following simple linear inequalities. Number 2. X plus 5 is greater than or equal to 2. In this particular inequality, we can apply subtraction property of inequality. Subtract 5 to both sides of the inequality. So from here, we have x plus 5 minus 5 is greater than or equal to 2 minus 5. We can just cancel 5 and negative 5 since they are additive inverse. Cancel out 5. So we have x is greater than or equal to negative 3. Consider x is greater than or equal to negative 3. We're going to draw it on the number line. So we have the number line here. from negative infinity up to positive infinity. Take note, class, we're going to draw a closed circle to negative 3. Okay? So as you can see, we have the closed circle here and a line segment to the right of negative 3. Since x is greater than or equal to negative 3. Hence, the solution set of x are negative 3, negative 2, negative 1, 0, 1, 2, up to positive infinity. Consider illustrative example number 3. Solve and graph the following simple linear inequalities. Number 3. P plus 8 is greater than 8. In this given inequality, we can just apply subtraction property of inequality. Subtract 8 to both sides of the inequality. So we have P plus 8 minus 8 is greater than 8 minus 8. Since 8 and negative 8 are additive inverse, we can just cancel 8 and negative 8. From here, we have P is greater than 0. Consider P is greater than 0. We're going to graph it on the number line. So consider the number line here. From negative infinity up to positive infinity. Take note, class, we're going to draw an open circle to 0. So as you can see, we have an open circle to 0, and we're going to draw a line segment to the right of 0, since P is greater than 0. Hence, the solution set of P are 1, 2, 3, 4, 5 up to positive infinity. Consider illustrative example number 4. Solve and graph the following simple linear inequalities. Number 4. K minus 10 is less than or equal to negative 5. In this particular inequality, we can simply apply addition property of inequality. We can just add 10 to both sides of the inequality. So we have K minus 10 plus 10 is less than or equal to negative 5 plus 10. Since negative 10 and positive 10 are additive inverse, we can cancel out negative 10 and positive 10. From here, K is less than or equal to 5. Let's graph. Consider K is less than or equal to 5. So we have the number line here. From negative infinity up to positive infinity. We're going to draw a closed circle to 5. So as you can see here. And we're going to draw a line segment to the left of 5. Since K is less than or equal to 5. Hence, the solution set of K are 5, 4, 3, 2, 1, 0, negative 1, up to negative infinity. Before we end our discussion for today, let me read to you a passage from the Bible coming from the book of Romans, chapter 15, verse 13. May the God of hope fill you with all joy and peace in faith, so that you overflow with hope by the power of the Holy Spirit. Take note, class, skills are developed through constant correct practice, and there will always be a room for improvement. That's all for today. Stand by for more lessons. Stay safe, everyone, and may God bless us all.